Okay, so solving other types of equations. That sounds very generic, and yes, it is. This unit is actually challenging in the sense that there's just a lot of different types of equations out there, and we need to be able to recognize what we're dealing with and what the best strategy is to go ahead and solve that equation. So if you look on your packet right above this section, beginning right here, you can see a couple of things that I've already put on there for you. So rational equations. We need to be able to recognize a rational equation. We have talked about the word rational quite a bit. Rational expressions, rational functions, all of that fun stuff. So rational numbers. Find the least common denominator, multiply every term by the least common denominator to get rid of all the denominators, and then solve the remaining equation. With rational equations, we have to check for extraneous solutions. Absolute value equations, try to isolate the absolute value, then drop the absolute value, create a positive and negative equation, solve each equation, and check for extraneous solutions. Factoring is going to be a big thing. So you're going to have to recognize different factoring scenarios. Always try to take out a greatest common factor if possible. That'll usually make things easier. You might have to do a substitution. You might think of that as a U substitution. You don't have to use the letter U though. It's really up to you. No pun intended there. Difference of squares, x squared minus y squared equals x plus y times x minus y. Difference of cubes, the sum of cubes. So these are two things that you probably haven't done in a while. Split the middle term, maybe factoring by grouping. So all of these techniques are going to be very important here. Extraneous solution. So remembering what is an extraneous solution and when do I have to look for extraneous solutions. So remember, an extraneous solution is a solution that was found correctly by doing all the correct algebra, but it does not make the original equation true. Possible scenarios for extraneous solution, absolute value equations, rational equations, or any time within the solution process that you end up squaring both sides of the equation. Any of those are possible scenarios of where you might get extraneous solutions and you have to check. Okay, so moving on to the first example. We have 9x to the fourth minus 24x cubed plus 16x squared equals 0. We're trying to solve. What's a good idea to do to solve? Well, this looks like a potential factoring problem to me. I see that I have a greatest common factor, so I want to take out the greatest common factor first. My greatest common factor is x squared. And I'm left with 9x squared minus 24x plus 16. Now I can factor this quadratic trinomial. This is actually a perfect square trinomial. You might not recognize that. If you do, that makes the problem easier. If you don't, that's okay. Remember, for factoring a trinomial, we can either do guess and check, or you could do split the middle term. It's up to you, whichever one you're more comfortable with. Some people like just doing guess and check and are better at that, and some people like doing split the middle term because it's a little more intuitive, or I should say a little more methodic, where there's a process that we go through, but it's really up to you. In this case, I'm going to do guess and check because I recognize that it is a perfect square trinomial, and I see that it's going to factor into 3x minus 4 times 3x minus 4. Now we just set each factor equal to 0. I don't need to set this equal to 0 twice because I know it's going to give me the same value. And I get x equals 0. And x equals 4/3. Those are my solutions. Here, this is a rational equation. So what did I say that we want to do for a rational equation? We want to find the least common denominator. So if I think about x squared minus 4, that is the difference of squares. I know that factors into x minus 2 times x plus 2. So since this is x minus 2 times x plus 2, this is a denominator of x plus 2, and the 3 has a denominator of 1. That means that my least common denominator is x minus 2 times x plus 2. So what did I say the easiest thing to do is to multiply everything, every single term on both sides, by the least common denominator. Why do we do that? Well, this is going to cancel all of the denominators. So when I multiply this term here in the numerator by x minus 2 times x plus 2, that just cancels, and I'm left with x plus, here the x plus 2 cancels, and I get 1 times x minus 2, and here I get 3 times x minus 2 times x plus 2. So now it's much easier to work with. The denominator is gone. So I want you to try to solve the rest of this. Pause the video, find your solutions, unpause when you're ready to check your work. I will give you a hint. You're going to have to do either the quadratic formula or complete the square to end up solving this. Okay, so we should end up with 1 plus or minus the square root of 31 all over 3. How do we get that? Well, I used the quadratic formula. So we stopped up here at the green. Distribute the 1. I get x plus x minus 2. I know that x minus 2 times x plus 2 is x squared minus 4. So I distribute the 3 and I get 3x squared minus 12. Bring everything over to one side and I get 3x squared minus 2x minus 10 equals 0. Again, I chose to use the quadratic formula. You could also complete the square. So opposite of b plus or minus the square root of b squared minus 4 times a times c over 2 times a. I know, it's really hard to say without singing, right? Yeah, no. So then we do 2 plus or minus the square root of 4 plus 120. 4 plus 120 is 124. 124 is 4 times 31, so it actually becomes 2 root 31 over 6. Since this is a 2, and this is a 2, and this is a 6, they all have a common factor of 2, and that's how I can reduce to 1 plus or minus root 31 over 3. Now, remember we said we have to check for extraneous solutions. Well, what are we looking for? With rational equations, all we're doing is we're checking if I plug in one of my solutions, does it make the denominator 0? The only thing that's going to make the denominator 0 would either be 2 or negative 2. Here it would be negative 2 as well. So if I look at my answer, this is clearly not a value of 2 or negative 2. So therefore it is not extraneous. Next one. X to the 6th minus 64. So this one's going to be kind of a doozy. Why? Well, what is this? This is the difference of squares. So x to the 6th is a perfect square. 64 is a perfect square. So this factors into x cubed plus 8 times x cubed minus 8. This now is the sum of cubes. This is the difference of cubes. So again, if you look back at your packet here, I gave you the formula for the difference of cubes and the pattern for the sum of cubes. I want you to try and factor these using that pattern and then continue to solve. One thing I will point out, the quadratic trinomial will never factor, so you're going to have to use the quadratic formula or complete the square to actually solve those pieces. So I want you to try to continue to solve this. You should end up with 6 answers. So if you don't get 6 answers, you did something wrong. Pause the video, unpause when you're ready to check your work. Okay, so we should end up with x equals negative 2, x equals positive 2, x equals 1 plus or minus I root 3, and x equals negative 1 plus or minus I root 3. So this is 1, 2, 3, 4, 5, 6 answers. Now, how do I get that? Well, x cubed plus 8 becomes x plus 2 times x squared minus 2x plus 4. So all I was doing was following the pattern here for the difference in sum of cubes. X cubed minus 8 is x minus 2 times x squared plus 2x plus 4. Now I set each factor equal to 0, so x plus 2 equals 0, x squared minus 2x plus 4 equals 0, x minus 2 equals 0, and x squared plus 2x plus 4 equals 0. X plus 2 equals 0 gives me x equals negative 2. X minus 2 equals 0 gives me x equals positive 2. I already told you these will not factor because nothing is going to multiply to 4 and add to negative 2, or multiply to 4 and add to positive 2. So I used the quadratic formula, and then as I simplified that, I ended up with 1 plus or minus I root 3. Now, you'll notice I didn't show all my work for this one because notice that the a, b, and c value, when we're talking about our standard formula quadratic equation, they're the same for both of these, except for b is just an opposite sign. So the only thing that's going to change in my answer is this 1 is going to be a negative 1 here, because here where it was positive 2, it's going to be negative 2. Everything else is the exact same number, so I don't have to do the work again. I know what the answer is going to be. But here you can at least see the setup. Next one. Square root of 5 minus x minus 3 equals 0. Well, what do we do if we have a square root in the equation? There's a couple things we can do. In this case, though, what's the best scenario is to isolate the root. So you want to get the square root by itself. So we'll have the square root of 5 minus x equals 3. Now what? Now we square both sides. So when I square both sides, this becomes 5 minus x equals 9. Now I can solve for x. If I add x and subtract 9, I get negative 4 equals x. Now, this was a scenario where I had to square both sides of the equation in order to solve. So I do need to check. I need to go back to the original equation, and if I do the square root of 5 minus negative 4 minus 3, does this equal 0? 5 minus negative 4 is actually 5 plus 4, so this becomes the square root of 9. This becomes 3. So I get 0 equals 0, therefore this is a good solution. Next one. This one you should be able to solve on your own, so I'm going to let you try to do this. If you're confused on what to do, factor by grouping. So pause the video and try this on your own. Unpause when you're ready to check your work. Okay, so here we should end up with x equals negative 2 and x equals plus or minus I root 3. How do we do that? Well, like I said, group. So I group the first two and I group the second two. I can take out an x squared from the first two, and I can take out a positive 3 from the second two. I'm left with x plus 2 and x plus 2 in the parentheses, therefore I know I've done this correctly. So now I can factor out an x plus 2, and I'm left with x squared plus 3. Set each factor equal to 0, and solve. This was just a polynomial equation, so I do not need to check for extraneous solutions. Okay, number 6. 9t to the 2/3 plus 24t to the 1/3 plus 16 equals 0. Alright, so a couple things that we need to remember here. Remember that t to the 1/3 is the same thing as the cube root of t. So t to the 2/3 is the same thing as the cube root of t squared. So this is an example where you could do a substitution if you want. You do not have to write this, but if it helps you, then do this. So I'm going to say that t to the 1/3 is actually x. And so then t to the 2/3 would be x squared, because this is the cube root of t squared, so this term is squared. So if you think about the problem 9x squared plus 24x plus 16 equals 0, we had a problem just like this in the very beginning. So we know that this factors into 3x plus 4 and 3x plus 4. Now I can set each factor equal to 0. But x is the cube root of t. So now we cube both sides and we get our answer. So we get negative 64 over 27.